Thank you, everyone. And also thank you to Julian and Anja for the invitation to speak here. So I want to talk a little bit about applying the skill tree to course classification and design, specifically an MPI course that I'm currently extending as part of an HPC NW tutorial. So please, everything basically in this course, in this presentation is still work in progress. So it should be regarded as just the basis of a discussion and my experiences here. So yeah, so I've been have like an on-off relationship with the HPC Certification Forum. I started to join several meetings, and I'm very into the idea, but I'm not, let's say, an active part in terms of having contributed much myself yet. So from what I understand and what I like about the idea of the skill tree was that for users, it should give an orientation of the different knowledge levels. So what should I know for a specific level? So what's the basics of a certain HPC topic that I should know? And it helps to provide self-assessment to see whether I am on the level that someone else defined for a certain topic. But it also provides this independently assessed level of personal knowledge after an exam, which is I think also still in preparation. So for the HPC centers, there you have the idea that you can better assess the user knowledge when someone basically first starts to work on your HPC system. There were like terms like the HPC Führerschein. Yeah, like some basic knowledge that people should have, and which probably still needs to be defined. And it also provides the possibilities to strategically improve the user's knowledge on specific HPC topics, because then if you basically can form a path to a specific level of knowledge, the users you can basically create a curriculum for them to basically successively participate in. Yeah? And it also leads to some form, let's say a loose form of standardization of the curricula that we have in HPC, because then for like this topic specifically, if we defined what basic MPI knowledge is, then a basic MPI course should basically cover at least that. So where do I come from in terms of trying to applying this? In Aachen, we have a 2-day introduction into MPI, which is part of PPCS, which is an annual workshop that lasts for a week. There's like 2 days OpenMP, 2 days MPI, and 1 day of an additional topic. And so we've taken these as a basis and want to extend those as an HPC online tutorial. And that unfortunately is still in development because it's a larger piece of work. And the idea there is to extend it to have a broader coverage of MPI, because with experiences of PPCS, we often had the problem that we were facing. Well, this is a new topic in MPI, and we should really teach people on this topic. But is this the basis? And at some point, you kind of have to juggle around which topics you can fill in a 2-day workshop, and people actually still take something home from that. So that is the starting point. So to decide which topics we should take and which topics are basic, first we need to make an initial assessment. So first, classify the skill level of the course content. Is the 2-day introduction that we have in PPCS, is that actually a basic course, or are we mixing topics? Should we have different topics in there? And then we only have loosely defined requirements for specific for the MPI course. Usually it's said, yeah, basic knowledge of MPI. We have an HPC introduction course that you should usually have participated in before it makes sense to participate in PPCS. But that's also very basic, and also it's it doesn't formally define a skill level that you have afterwards. So we don't have a formal skill level of requirements yet. And then the question is, MPI is quite a big topic, and we'll have to look through the content of the API and the standard to see which part should be grouped into basic, intermediate, or expert level. So, and that is basically what I want to present today is the idea where I would see the different parts of MPI in terms of the skill levels, and bring that to a discussion of whether we should juggle around different topics and how to manage the problems that I already faced in classification. So I think the main skill that an MPI course will develop is SD123, which is programming message passing systems. And when I look into the wiki on hpccertification.org, there's only a basic description on it, but personally, I feel fine with MPI being the de facto standard in HPC to have this skill be fairly MPI centric, even though I'm quite aware that MPI might not be the only message passing interface that you could use. Then you also have some relation to other skills here, namely in the section K of HPC knowledge, where you have level of parallelization, parallelization overheads, domain decompositions. Those are all additional skills that you potentially should have or will develop by understanding programming message passing systems. So they're touched, and we'll have to discuss on how to integrate those. But for now, I would not cover HPC knowledge or classification in HPC knowledge, and more focus on the SD123, which is programming message passing systems. So looking at the wiki, we see that for the basic knowledge, we have the blocking versus non-blocking. And for PPCS, we say, well, yes, we have that, certainly. And I think most of us will agree that point-to-point blocking and non-blocking point-to-point communication is kind of what is contained in any basic MPI course. And the wiki also lists point-to-point versus collective communication, so I could easily agree on that as well, that collective communication is one of the greater benefits of the MPI standard, that it basically defines collective communication primitives that have some form of built-in optimization compared to manual reprogramming programming it on a point-to-point level. So then the wiki page currently also says or states detect race conditions and deadlocks. And there was my first, the first situation where I thought, well, would detecting race conditions and deadlocks be a basic skill in programming message passing systems? Certainly, I would think this is important, because if you have a race condition or a deadlock and you don't know how to work with those, or how to get rid of those, you'll forever be stuck in that basic level. However, detecting those race conditions and deadlocks, for me as a tools person, my background is in performance tools, mostly focusing on API. I think detecting is also more on actually using the tools to either check whether you have them, detect where they are, and fix them. Those are higher level skills, and probably also part of a different skill. So here I would probably rename this to understand race conditions and deadlocks, so that when you program message passing systems, you should be aware of what can happen and what should not happen, and but it's still a step further whether you can actually detect those. Yeah. So the understanding for me was more of the basic level of message passing systems. So the same kind of applies to assess the impact of communication synchronization on program performance. So here again, I would think assessing the impact actually is part of performance engineering, because there you learn about measurement techniques and profiling, tracing, and so on. And those are the tools where you can actually assess the impact of communication synchronization on program performance. But the understanding for the problems you should teach in the programming of message passing systems. Yeah. So here, in principle, I think I'm okay with the general topics, but I would rephrase the semantics a little bit. Yeah. And as I said, the detection and the assessment are more part of different skills, I would say. But I'm happy to discuss this with you. So, and then it seems the intermediate knowledge and also the expert knowledge are still not very fleshed out, because they basically have the same kind of topics, where it's still understanding the impact of communication synchronization, program performance, but the question is what else? Yeah, and we'll come to that in a moment. And for expert knowledge, we have the same thing, but we also have the concept of overlay networks mentioned in the skill at the moment. And there I wondered, what is meant here? Is that virtual topologies? And why is virtual topologies a topic for expert knowledge, not necessarily intermediate knowledge? Because I think virtual topologies are actually an interesting abstraction in MPI, and that should be something that should come rather earlier than later. I think part of the expert knowledge would then be how to tune for that, how to map the virtual topology to the hardware topology of your system. So, okay, so that as the let's say initial set of thoughts on what to do. Like when I said, well, okay, I want to expand the MPI curriculum, and where should I put what, and to see what kind of guidance I had from the current skill definition. So personally, I think the semantic terms are crucial for understanding MPI and on any level. So semantic terms should be, in my regard, always in all basic. It should be the basis of any MPI tutorial. And here we have blocking versus non-blocking, also collective versus non-collective, but also, which has been a little bit clarified in MPI 4.0, the local versus non-local discussion. And I think those terms are very important to understand, because that means you start to understand the behavior of certain functions when you say when you realize that a certain function is non-local, yeah, and what it does or what it could do because of that. So that for me is basic knowledge. So and then we already said point-to-point communication should also be is the basic building block of message passing. So that should be basic as well. But there are different kinds of point-to-point communication where you have blocking, non-blocking, where we all already said, yeah, that should be part of the basic MPI building block. But then there's also persistent communication, which is kind of like extension of non-blocking. And with MPI 4.0, you now also have partition communication, where you have, which is an extension of persistent communication. And with my current proposal, I would see persistent as an intermediate concept, and partitioning then to build up as as an expert level knowledge, to build up on the intermediate level knowledge of persistence. However, personally, I think the partitioned communication that was introduced with MPI 4.0 actually also is a concept that can benefit people earlier. And but it kind of it's hard to fit it all into one category. Yeah? So at some point you have to allow things to spill into or to be collected in the expert knowledge part. So then personally, I think data types are also crucial in understanding MPI, because it's one of the fundamental abstractions that you have. Yeah, you need to understand type maps and type signatures to be able to understand what actually happens when you have a send and a receive, and whether you can have like that account and the type form the type signature, and those have to match for a successful transformation. But then that you can also, with derived types, can also have in-flight transpose matrices and things like that, and you can have non-contiguous accesses in your memory. So that is also something that I think even novice users should be exposed to. Yeah, they don't need to use that right away, but they should be exposed to that it's there. Otherwise, you start seeing for loops with send, with individual sends and all that in novice user codes. Okay. Then we also said collective communication should also be part of the communication of the basic building block, but there we also have blocking, non-blocking, persistent, and neighborhood. And for PBCS, there, so in principle, I said, well, when you understood the blocking and non-blocking of point-to-point communication, it should be a smaller step to understand both blocking and non-blocking both non-blocking versions of collective communication. So in principle, I would both bring them into or classify them as basic knowledge. However, we already saw in PPCS that we never find the time to actually cover the non-blocking collectives in there. So that kind of swoops into the intermediate basket, where if we ever have an extension like intermediate level course after PPCS, there we would certainly cover collective, non-blocking collective communication. So, but here we already see one of the problems that I had with classification, because now we kind of have a skewed level of coverage. We have non-blocking that is actually known but not covered here due to time restrictions, but it should be something that should be easily teachable. Yeah. And again, if you've understood non-blocking collectives, persistent is also not that much of a leap to get right. So, but still, we said persistence is an intermediate concept. So you don't really know persistent. So it's not clear whether you can actually have persistent collective communication already in the intermediate level course. So that would be, or that could be part of the expert level, because it also, the persistence is actually exploring tuning opportunities for codes if you reuse requests and so on. And then there's something that I've been thinking about for a long time on whether I could incorporate things like this in PPCS, but to no surprise, I've never found the time. And also now the neighborhood collectives, they ended up in the expert level classification, because I at some point had the virtual topologies as an intermediate concept. And then the idea is that you introduce the intermediate, or introduce the concept and have basic understanding of how to use it, which would be, for example, in point-to-point communication. So the neighborhood collectives that make use of Cartesian and graph topologies, they would be a concept that you don't necessarily need when you want to use virtual topologies. So you could get by with using virtual topologies with point-to-point and take the next step in your expertise by actually applying those in neighborhood collectives. So then we have groups and communicators. That is also something where I say the intra-communicators. Actually, there are like two parts of groups and communicators that people should understand. And the first one is basic, because people should kind of understand, or they need to understand what a communicator is, because it's basically the bread and butter of MPI. It's the communication context abstraction that is provided with MPI-COM world and MPI-COM self. And but there's also this strange brother to normal intra-communicators like MPI-COM world, which are intercommunicators. And then I put into the expert level, because they're not, you see more and more use of them, but I think in a very specialized setting. So I would be okay with having those to be an expert level feature. And then process topologies, I already said that actually for me then it would be an intermediate topic, and yeah, there's not much to be said there. Info objects as well, I would see as an intermediate topic, because at the beginning you can get by with just providing MPI info null to any call that that allows you to provide an info object, and it's more of an exploration tool for tuning opportunities, which I'm fine with having that as the idea for intermediate knowledge level. And but then again, info objects are so simple that they can easily be taught earlier than the expert level. Then with MPI 4.0, we have to cover different process initialization models. And so the basic, which is now called the world model with MPI init and MPI init thread, that is something that that is also, it's needed. Otherwise, you can't write a single correct MPI program. And if you have an MPI only application, like single-threaded initialization, that should be taught everywhere. And then with using MPI init thread, there was starting to be unsure, because that has a cross-cutting to a different skill. And then can I use hybrid initialization here as a basic skill, because that means MPI, the basic MPI course, would have a requirement for the basic shared memory programming course, or skill in that sense. And that was weird. So hybrid initialization is something that I would also think is important to understand, but might spill over into the intermediate box. For PPCS, we solved this by having 2 days of OpenMP right in front of the 2 days of MPI. So we can just refer to, yesterday you heard about threading. So if you want to combine the two concepts, this is what you need to do. So, and then with MPI 4.0, you get the sessions model. And the sessions model is something where I would think you could get by not knowing about it for the first steps in MPI. So that's why I would...
Marc-Andre,
yes.
Thank you. I may interrupt you a little bit. How long do you want to keep going? I mean, this is really interesting, and I think you made your point.
Okay, so so in general, I think this is I have 5 more slides, but if you think, well, I can basically skip off the rest of the classification.
Yeah, I think so. I think that
okay.
I mean, this discussion, I think we really understand your rationales. I think there's some stuff that we can discuss later, but there's no need to keep going on individual examples. Okay, yeah, that's fine. That's fine. So so let's skip to the proposed curriculum. So, and that is basically where I would say, well, if the community is fine with this, I think this should be somewhat the basis for the skill descriptions that we provide in the skill tree, right? So, so first, semantic terms, process initialization, only the word model, blocking, non-blocking, point-to-point, data types, and as I said, the problem with collective communication and groups and communicators, the basic ones. And for intermediate ones, I would then extend to the sessions model, and then introduce persistence, and then do the next step in collective communication. Personally, I also would add one-sided communication, because even though it's complex, the question there is, it provides a good communication abstraction, but it's largely unknown because it's largely untaught. And so there, I think it should get a more more an earlier introduction, although I can basically see that it's not an basic level course. I/O, we just had an accelerate focusing on I/O. I think it's a very important part there. And then again, the next parts would be that the intermediate and then again also the expert levels should extend on from the understanding of the functionality to more of an understanding of how the behavior and performance is there. And then you can have basically require certain basic skills from other parts of the skill tree. So, and then that leaves us with basically all the rest in the expert level here. So the question that arose is what to do with related skills. We have domain decomposition, which is K3.3. We have load balancing, which is also in the software development part, but it's a different skill. We have performance engineering, which is a complete different branch, and we have I/O programming, talking about MPI/I/O. Where should that kind of reside? Because it's not a classic message passing part, but it's part of MPI. So, and that is something where I would really like the input from the community on where your stance is here. Personally, I think it shouldn't be part of the course itself, but it could be used in exercises, like Halo Exchange and part of that. So with that, it would be a requirement to have a basic understanding of a certain other skill for the basic course in MPI and message passing. So then the question is, is my assessment correct that a good approach is to focus on functionality first, understand what's available, and then focus on performance later? Or should we directly focus on specific, let's say, behavioral aspects of certain routines available in message passing? So as a summary, like the current skill tree is still a work in progress, needs extending, and my proposal of how to extend that is what I've presented here. What I struggled with the most is that the skill definition needs to be precise enough to have a full coverage of a block. Otherwise, if you have a course that labels, well, we teach SD123B basic, a user would assume that basically teaches the full spectrum of SD123B and not only parts of it. So and with a large standard like MPI, it's the question is, do we need further differentiation and how to proceed on that? And like, is there a maximum depth of the skill tree that we should allow? And that is basically what I just said, that with large interfaces like MPI, you easily get into problems where you have time constraints to have small courses and small blocks of knowledge that should basically cover a complete basic, intermediate, or expert level of a skill. And and you have the problems which I briefly touched with MPI/I/O, where to put that. It's part of MPI. It's not so much message passing, but it uses concepts like communicators and handles and so on. So it should be taught in an MPI context. It's kind of weird where to put that.
And for the complex relationships that we have with the knowledge part is how do we ensure that the requirements of the course are known and met? Like if I design an exercise for MPI, I can say, oh, well, okay, I'll do a ghost cell exchange in my exercise, but how do I know that what I do there is actually fulfilled by a domain decomposition basic course, or am I doing something that is a domain decomposition intermediate level? So that is something where I'm not. Yeah, it wasn't easy for me to assess on how to place the levels and for the requirements. Yeah, and then the question is how do we encode optional knowledge, and how do we build paths from like a completely novice user to the expert level on like which courses to take by defining the dependencies. Yeah, so that should be it for now. So thanks for your attention so far. Sorry for the vast level of detail on this.
Okay, thank you very much.